If you tear down an AirPod, you'll come across this green piece. This is a printed circuit board. This tiny piece of board is the heart of any electronic device. It's quite fascinating how a huge number of tiny components are connected to each other via such a small printed circuit board. You'll be even more amazed to know that it's possible to extract approximately 0.3 grams of gold from the PCBs in your laptop. Here is a PCB manufactured by JLC PCB, which has a gold-plated connector. Later in the video, we'll explore how to extract the gold from it. Let's take a look at the interesting process of producing the PCB for the AirPod. In the first step, we will design the PCB with the help of EasyEDA software. EasyEDA is a free design software that can even generate a 3D view of the PCB design. Before seeing how it's designed, we'll fabricate it. The first step is to make a printout of this design with the help of a plotted printer. The printout is produced on a plastic sheet with a photo negative of the circuit in black ink. Now we want copper on the top layer of PCB except for the area underneath the black ink. To achieve this, we can take a copper plate and place the printout on it along with the photoresist layer. Let's place this setup under a UV light so the photoresist layer can harden. When we place our printout on a photoresist layer, the light passes through the clear parts of the printout and hardens the photoresist, whereas the black ink in the printout prevents the light from reaching the areas not meant to harden. Now it's time to remove copper from the unhardened area with the help of a few different chemicals. Finally, our PCB has been fabricated. Let's protect our copper areas with a solder mask. After proper optical inspection, it's ready to mount components on it. This video provided by JLC PCB shows how components are fitted on the PCB in a factory. We are done with the PCB fabrication, but there is a big issue. This PCB is too big to fit in the AirPod. We need to reduce its size. We can't reduce the gap between components since the traces will overlap. We also cannot reduce the thickness of the traces or the distance between the traces. The thickness of the trace depends on how much current is flowing on it. This issue can be resolved by providing some traces and components on the other side of the PCB. This is the double-sided PCB. We can now fit this smaller PCB in our AirPods. However, using the earphones at this stage will be unpleasant, as the sound quality will be very poor. This is because of an issue called interference. We place the components or traces so close to one another that they interfere with one another. A current flowing in one trace generates a magnetic field that affects another trace's current. In addition, the close proximity of two metal traces starts to act as a capacitor. As a result, the voltage is changing. This issue becomes more serious with high-frequency signals. This is why multi-layer technology is used in modern PCBs. The interference issue can be minimized by separating out the ground layer and the power layers. To separate these layers electrically, insulating layers are added between them. The number of layers is determined based on the requirement, which can go as high as 12 or more. When they are all ready, they're tightly pressed together with insulator layers alternately. This video, provided by JLC PCB, shows how lamination is done during manufacturing. These layers are electrically connected through various types of vias and are fabricated using a mechanical drill or a laser machine. The other vias you'll notice atop the PCB act as heat sinks. They allow heat to be transferred from the components or traces to the outside. As we saw earlier, some PCBs contain gold. Gold is not only conductive, but also highly resistant to oxidation and corrosion. Since it is expensive, it's used only as a plating on the edge connectors. You can find it in your laptop where the SSD or graphic card is connected to the motherboard. Now, let's see how to extract gold from the PCB. First, we'll submerge this PCB in nitric acid for a week. This will melt the copper and plastic, leaving only the gold intact. Next, we filter out this solution and heat it up to turn gold flakes into a single chunk. Let's see how to design a circuit board with the help of EasyEDA, a free software. We must first make a schematic circuit for a Bluetooth headset in software. With the help of the Convert to PCB option in EasyEDA, we can automatically convert the schematic into PCB. The Convert to PCB option brings the footprint of each component and all the connections in the PCB outline. In the next step, we need to place component footprints inside the PCB outline and arrange them according to our requirements along with the traces. We now have the software version of our PCB. In this example, the red area represents the copper area, and the black color represents the non-copper area. After EasyEDA completes the PCB design, you can directly connect to JLC PCB to place an order. JLC PCB is a reliable manufacturer that delivers PCBs quickly and at a lower price. Thank you for watching the video. We hope you enjoyed it. Before you leave, don't forget to join the Lesix team.